You know, we've all seen how the digital computer completely changed the world. It feels like we've reached the peak, right? Well, what if I told you the next great leap, something even bigger, is already here? We are standing right at the dawn of a new technological age, and the quantum revolution is set to reshape our world in ways we can barely even start to imagine.
Okay, let's just pause on that for a second. That's a huge statement from physicist Dr. Michio Kaku, and honestly, it nails the stakes perfectly. The race to build a working quantum computer isn't just some fun science project. Oh no, it's a massive economic and national security issue. All the big players, tech giants, governments, you name it, they're pouring billions into this. Why? Because falling behind means getting left in the digital, or maybe I should say the quantum, dust.
So what is this thing, really? First, forget about just the faster version of your laptop. That's not what we're talking about. We are talking about a totally new kind of machine, the ultimate computer. It's a computer that doesn't work on silicon chips, but on the literal building blocks of reality itself, on individual atoms. To really get just how big of a deal this is, we gotta take a quick look back at how we even got here. It's a really cool story, actually, of 3 major shifts in computing that have led us right to this moment. So this whole journey started about 2,000 years ago with these super intricate analog computers. Think of the Antikythera mechanism, a crazy contraption of gears found in an ancient shipwreck that could actually predict the movement of the stars. Fast forward to the 1800s, and you've got Charles Babbage's mechanical engines, clanking away, calculating tables for the industrial age. But the real game changer, the one we all know, was the digital computer born out of World War II. It used simple zeros and ones to crack enemy codes. And that brings us to today, the beginning of the quantum era.
So, what is the secret sauce? What makes this new era so revolutionary? Well, it all comes down to the one single, fundamental piece of information it uses. And this is where things get, well, pretty weird and unbelievably powerful.
Okay, have a look at this. The computer or phone you're on right now uses what we call digital bits. A bit is super simple. It's like a light switch. It's either on, a 1, or it's off, a 0. That's it. But a quantum computer, it uses a qubit. And a qubit isn't a light switch. It's more like a dimmer dial. It can be 0, it can be 1, or it can be any possible value in between. And here's the kicker. It can be all of them at the exact same time.
Yeah, I know how that sounds. This bizarre, mind-bending property is called superposition. How can something be in multiple states at once? Well, here's an analogy. Imagine a coin spinning in the air. While it's spinning, is it heads or tails? It's kind of neither, right? But in a way, it's also kind of both. Only when it lands, only when you measure it, does it actually lock into one definite state. That, in a nutshell, is the magic of superposition. So here's the punchline. A quantum computer basically puts that spinning coin to work. It runs calculations while its qubits are in all of their possible states at the same time. It's like it gets to explore every single potential outcome at once, almost as if it were computing in thousands, even millions of parallel universes simultaneously. This is what lets it solve problems that are literally impossible for the computers we have today. I mean, problems that would take our best supercomputers longer than the entire age of the universe to figure out.
Now here's what's really wild, how this power scales up. With a regular computer, power grows in a straight line. You add more bits, you get a little more power. Simple. But a quantum computer's power grows exponentially. Every single qubit you add doubles its total processing space. That's why a machine with just a few thousand stable qubits could already be more powerful than a supercomputer with billions of bits. And we're just getting started.
Of course, if it were that simple, we'd probably all have quantum laptops by now. The truth is, there is one enormous, incredibly difficult problem that scientists are fighting tooth and nail to overcome.
So, what is it? What's the one thing? The single biggest challenge that's holding this whole revolution back? What is the Achilles heel of the quantum computer?
The answer is one word: decoherence. You see, those delicate spinning coin states, that superposition, it's unbelievably fragile. A calculation only works if all the quantum waves are vibrating together in perfect harmony. That's called coherence. But the tiniest little thing, a stray vibration, a tiny change in temperature, can make them fall out of sync. And just like that, the calculation collapses into pure, useless noise. Right now, our solution is pretty much brute force. We build these massive, complex refrigerators to chill the computer down to temperatures colder than deep space, just to keep everything stable. But here's the amazing part, the part that blows my mind. Nature already solved this problem. photosynthesis. The process plants use to turn sunlight into energy is a perfect quantum calculation, and it happens at room temperature. It turns out Mother Nature is still the best quantum engineer in the universe.
So, even with these incredible challenges, the race is on. Why? Because the payoff, well, it's almost unimaginable. We're not just talking about making faster computers. We are talking about unlocking a whole new era of human discovery.
Let's just think about two of humanity's biggest challenges: food and energy. A quantum computer could finally crack the secret of how plants make fertilizer out of thin air, which would totally revolutionize agriculture. Or it could help us finally control the super hot plasma inside a fusion reactor, giving us that dream of clean, limitless energy for good.
And now think about medicine. This is where it gets really personal. Diseases like Alzheimer's, Parkinson's, so many cancers, at their core, they're problems at the molecular level. They're way too complex for our current computers to simulate accurately. But a quantum computer thinks like a molecule. It could let us design drugs, atom by atom, to attack these diseases at their very source. The goal here is nothing less than to cure the incurable. And beyond all these incredible, world-changing applications, there's an even deeper prize. Dr. Kaku believes these machines will finally give us the power we need to solve the equations of a theory of everything, the holy grail of physics that even Einstein couldn't find. One single theory to explain our entire cosmos from the Big Bang to the inside of a black hole.
So from curing diseases to understanding the very fabric of the universe, the potential of quantum computing is just staggering. The road ahead is definitely not going to be easy, but the rewards are incredible. And as we stand here right on the edge of this new world, the real question isn't if we'll unlock the secrets of the universe, but which ones we'll decide to unlock first.